Okay, we're looking at the money that flows in a short interval at time little t. And it's going to grow until the time is big T, right?
Right.
So how long does it have?
Big T minus little t.
Yeah. Okay.
Sorry, Derek.
That's it.
So if this is how long it has to grow, and this is what you start with, what does this tell you? Well, the thing that's maybe a little confusing is this is a rule, and this little t has nothing to do with this little t. This is a time it has to, this is how much you have after this much time has passed, right? Well, this is how much time's going to pass, okay? So it's going to grow to this, right?
Right.
Okay? That makes sense?
Yeah, the time it has to grow is the little t, which is big T
Yeah, but
minus
see, I'm
that
using little t twice here
Yeah.
because that's the way the world comes at you.
Right.
I could have used a different variable up here. I could have called this tau, or I could have called this t sub I star,
Right.
right? And if I had, the notation would have made it easier for you to figure it out, right? But I wanted you to think a little bit. But, you know, at some point, it's too much. So I could say, let's say this is now t sub I star, okay? And now the notation becomes a little clearer. Your time is t sub I star. You're going to grow till time is t, so that's going to be this, right? And now your t is always now t sub I star when we're just talking about a little increment, right? Okay? And this is f of t sub I star. The star doesn't go on the I, it goes on the t. Okay? Now this might be a little more familiar. Okay? So here's your amount. Now, if we sum this amount up, and we'll call this now delta p sub I. This is a contribution to your final principal of this, the money that flows in during some small time increment at time t sub I star. Okay? So, the total amount approximately the sum of f of t sub I star e to the r times t minus t sub I star delta t, right? And this approaches then the integral from 0 to big T, implicitly assuming that we start at time 0, right? Of this. Okay? Now, this is of the form right? Yeah, this is a function of big T minus little t. This is function T, and it goes from 0 to big T. Okay? And that's an example of a convolution. Now, the general definition of a convolution. And actually, now that I think about it, I'm not sure if it's lambda minus t or t minus lambda. And it's g of lambda, not g of t. And your integral is with respect to lambda, because t is the upper limit on this integral. Okay? But we see how this is exactly the same form as this. Now the g is, I've used the t minus lambda on f and the lambda on g because that's what your textbook does. Okay? But there we have a convolution integral. Okay? And this is important. If we want to find the Laplace transform of a product, and that's what we're going to work toward.
I was going to say that looks a lot like a Laplace when you do 0 to big T. And
Yeah,
T.
yeah, exactly. You got the e to the negative
Right.
ts and all that stuff, right?
Right.
Okay, so let's see how this works out.